Okay, welcome back then to some more integration. Lesson 3 on this, areas and the curves. As we saw last time in the checking question, definite integration tells you the area trapped between a curve and the x-axis. Okay, and the limits of integration tell us where the starting point and ending point of the area is. So for example, if I had this integral here, 1 to 4 of x squared dx, that would tell me the area trapped under the curve x squared between 1 and 4 on the x-axis. And this process is amazing because now you can find the exact area under a curve. Remember at GCSE, sometimes we had to count squares or perhaps use the trapezium rule, which was good, but it was only an approximation. Now we can get the exact right answer, which would be brilliant for us, okay? Integration is truly amazing. So example 1, perhaps pause the video and write this down, and then come back to me in, say, a minute or so, and we'll go through the question. Thank you. Okay, welcome back. My function's here, okay? So I'm going to write this down first of all on a blank slide. And it's asking us to find the, critical points of the function. Remember, from our previous work on quadratic inequalities, remember, the critical points of a function are where it crosses the x-axis, and that is when y equals 0, okay? So I need y equals 0, which means that 49 minus x squared equals 0. Okay, I've turned it around at the same time as well. All right, now 2 ways to solve this. I will actually make this into a quadratic. I'm going to take the x squared over here to make it positive. The 49 will become negative, and I'm going to turn it around in my head again. And you get this. Now look, it's my old friend, the difference of 2 squares. So this factorizes to this. And this means that x equals -7 is one critical point, and x equals 7 is the other critical point. Done that. Now sketch the graph of the function. Well, here I go then. Y, x, 0. Now remember, -7 is one critical point. 7 is the other one. And now what shape will this graph be? Well, you notice this is quadratic. So it's going to be a parabola. But either it's a U or an upside down U. And you can see it's actually going to be an upside down U, an inverted parabola, because of this minus x squared here. Okay, if it's negative x squared coefficient, it's going to be upside down. So this function, it's going to be hard for me to draw. Sorry, I'll try my best though, okay? Yeah, it's supposed to be a smooth parabola, okay? It's hard to do on this tablet at the moment. And this is the function. Okay? And that's done. Now I've got to find the area bounded by the curve and the x-axis. Bounded just means trapped. So if I do it in blue, you'll see that I need this area here, okay? It's trapped under the curve by the x-axis. So this top section of the curve here. All right? And if you want the area, the amazing thing is now, okay, is the definite integral of the function. All right, and remember, -7 is my starting point, and 7 is my end point. So I'll do my integration right from last lesson. 49x minus x cubed over 3. Remember, no need for the plus c, it cancels out. 7, -7. Now find your upper limit. Remember, that's going to be 49 times 7. Take away 7 cubed over 3. And the lower limit's going to be 49 times -7. I put brackets down here, okay? It's pretty important that if you're doing negative numbers to put them in brackets. And let's see what we get. So the first one, 49 times 7. Take away 7 cubed over 3 is 686 over 3. And this one then, 49 times -7. Take away fraction -7 brackets cubed over 3 is the exact same but negative quantity. And now to finish off, subtract the 2, okay, and you're going to end up getting 1,372 over 3 square units. You can put as a decimal if you want, but you get 457.333. I'd rather leave it as a fraction. So that's example 1. Quick time check. Not bad at all. Okay, so back to the PowerPoint. Next one, pause the video, write it down, okay, then come back to me. So the function was y equals 2x minus x squared plus 15. Okay, so I need, remember the critical points, I need y equals 0. So that means that 2x minus x squared at 15 equals 0. But I would like a positive x squared term. So I'll take everything here over to the right-hand side, which means the signs will change. And this is what you get. This will easily factorize to, I think it's -5 plus 3. So the critical points are x equals 5 and x equals -3. Now we sketch the graph of the function. Okay. Y x 0. So -3, 5. And again, it's going to be an upside down parabola because of this minus x squared here, okay? So here I go. Tiny bit better. Label the function. And we're done. Then it wanted the area now, okay? So again, I'll do it in blue. It wants this area here, okay? But we know integration's amazing. So the area is going to be the integral of the function from -3 to 5, okay? So if we integrate this function now, you're going to get 2x squared over 2, take away x cubed over 3 plus 15x between the two limits. If you work out the upper limit by doing 2 times 5 squared over 2, take away 5 cubed over 3 plus 15 times 5, you get 175 over 3. The lower limit, lots of brackets will be needed here, I think, somehow. You end up getting -27. Subtract the 2 now, and you get the area is 256 over 3. Again, it's going to be a decimal, all right? But I like it like the fraction. Remember, this is measured in square units, okay? Hopefully that all made sense. For the main task now, there we go. There's 4 to do. So if you pause the video, have a go, and then come back to me. I will show the answers in a short while when you come back to me. Thanks. Okay, welcome back. The answers are as follows. 243 over 2. Well, these are all units squared. 125 over 6. Question 3, I got 2048 over 3. And question 4, I turn my page over, is awful. 6,859 over 24. And obviously these are all in square units. I'll just do a quick time check. Yeah, we should be okay. for the checking question. Produce a sketch of the graph of this function. Find the area bounded by the curve and interpret your result. Okay, so pause the video, write this function down, and we'll do the same thing as before. So let's rock it. Okay, so I got y equals x squared minus 5x plus 4, just checking. So to sketch it, remember, critical points first of all. Y equals 0, okay? That means that x squared minus 5x add 4 equals 0. And this already is a nice quadratic. It's got positive x squared. This will easily factorize to this. So that means that x equals 1 and x equals 4 are the critical values. Okay. So better sketch the graph now, then we have the function. So let's rock out, let's rock out a very wonky axis, y 0, x 1 and 4. And this time it's going to be positive parabola because it's a positive x squared here, okay? So this one is in a more traditional parabola like this, and that's y equals x squared minus 5x add 4, okay? Now it's asking us for the area now, trapped between the curve and the x-axis. But can you see that this time round, the area trapped between the curve and the x-axis, there's nothing above. There's no area here trapped between the x-axis. This goes on forever. This here is my trapped area. It's below the x-axis. Bear that in mind because the answer might surprise you. All right? But the area is the same though, okay? It's still a definite integral of the function from 1 to 4 in this case. I'm not going to show you all the integration method, but let's just say that we know this goes to x cubed over 3 plus 5x squared over 2 plus 4x. The c's will cancel out. Okay, from 4 to 1. If you work out your upper and lower limits and subtract them, okay, then I'll leave that to you guys. You end up getting the area is negative 9 over 2 unit squares. Okay, or negative 4.5 unit squares. And hopefully this makes sense to you guys. See, because in the main task and all the explanations, see, the area was always above the x-axis. See, that's above. That's above. And all the main task ones are above as well. This one is below the x-axis. Okay, so this negative here tells you the area is under the axis. All right, so I'll make a note. Okay, a negative area means it is trapped or bounded below the x-axis. Okay, so this area is actually 9 halves unit squares, okay, but it's below the x-axis, hence the negative sign. So bear that in mind. Okay, I'll leave it there then. All right, thanks for listening and watching, and hopefully I'll see you soon. Thanks.